This recording is to help you with lesson 9.01, sequences and summation notation. Now hopefully this is going to be more review for you, and because you'll remember some of your sequences from Algebra 2. So we're just going to start out with the basics, and we're going to write the first 5 terms of a sequence if we're given an equation. And our sequences will usually be a sub n, where you're filling a value in for n somewhere. And since we want to find the first 5 numbers, we'll start with n being 1, 2, 3, 4, and 5. So this should be a 2. So let's plug 1 in for n and see what we get. Negative 2 to the first power is a negative 2. To find the second term, we plug 2 in for n, we get a positive 4. For the third term, we plug 3 in for n and get a negative 8. For the fourth term, we get a positive 16. And for the fifth term, we get a negative 32. Here we're going to find the indicated term of the sequence. So basically you're looking to see what we're going to plug in for n. And in this case it's really tiny, but that does say 25. So negative 1 to the 25th power, 3 times 25 minus 2. So I'm going to work inside parentheses first. So 75 minus 2 is 73. And negative 1 to the 25th power, because it's odd, the exponent's odd, it's going to stay negative 1. So negative 1 times positive 73 gives me a negative 73 for the 25th term of this sequence. All right, let's match the sequence with its graph. I think the easiest thing is just to create ordered pairs and see what they look like. So when you plug 1 in for n, we get 8 over 1 plus 1 is 2. So 8 divided by 2 is 4. So really we have a point at 1, 4. The second term is 8/3. So 2 and 8/3 for a point. It's got to be on my graph. The third term, 8 over 4 is 2. So we should have a point 32. And then so forth. We can go all the way up to 10 if we want. So that's 8 over 11. So we can have the point 10 and 8/11 on there. And once we start plotting those, we know that it matches up with graph C then. All right, factorial should be review also, so that exclamation mark means a factorial. And factorials mean you start with that number and then you multiply backwards all the way to number 1. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And in the denominator, 8 factorial is 8, 7, 6, 5, 4, 3, 2, 1. And before you actually multiply and try to reduce, let's cancel out anything that they have in common. It'll make our lives a lot easier here. So we notice they have 8, 7, 6, 5, 4, 3, 2, 1 in common. So let's cancel those out. And really all that's left is 10 times 9 in the numerator, which gives us our 90. For the next one here, let's write an expression for the most apparent nth term of the sequence. We're assuming that n begins with 1. All right, so basically we have this generic formula right here. We learned this in Algebra 2 as well, so I'm just kind of bringing it back up for you. A sub n equals a sub 1 plus n minus 1 times d. Remember, a sub 1 is your first term, and I'll write this here. So first term, n is how many terms we have in the sequence, and d is what we're calling our difference. So what you're adding or subtracting to get to the next number in your sequence. Okay, so for this one, our first term is 1. And D looks like we're adding 3 each time, so it's going to be a positive 3. All right, let's distribute that 3 through the parentheses and then combine like terms. And we get 3n minus 2 for my equation. Okay, to find the sum, it looks like we're starting with 0 and ending with 3. So I just wrote 0, 1, 2, and 3 here. I know I'm starting with 0 because that's what it tells me on the bottom of my summation. And I know I'm ending with 3 because that's what it tells me on the top. So when I plug 0 in for k, I get 1 over 1, which is 1. When I plug 1 in for k, I get 1 squared is 1 plus 1 is 2, so I get 1/2. When I plug 2 in for k, I get 1/5. And when I plug 3 in for k, I get 1/10. So when I'm adding these together, I know they need a common denominator of 10. And that leaves me with 15, 16, 17, 18 over 10. Divide that each number by 2, and I get my 9/5 for my sum. And the last thing, let's kind of work backwards. If I'm given the sequence, let's actually use sigma notation to write that sum. So we need to figure out what exactly is different from each thing here. Well, the 2 is the same in each. Right? So everything has a 2. So I'm going to start by writing that. Now, it appears that the numerator of my fraction is changing. Since the numerator is changing, I'm going to let that represent a variable, because a variable can change. In this case, we're going to let it be I. It looks like the denominator of every fraction is 8, and it looks like I'm adding 3 each time. All right, well, we need to figure out what number is I starting with, and what number is I ending with. Well, the number it's starting with is 1, because that's the first numerator of a fraction, and it's ending with 8, because that's the last numerator here. It's 8. So here is our sigma notation for that sum.